Am I audible? 21. I'm sharing my screen. My screen is visible. Okay. How many students? 20. Okay. So let's come to shear force and bending moment diagram. So you have we have seen the two main steps to draw the free body diagram, then find the support reaction. So see, this is if this is a beam, you are getting two reactions. You need suppose you need to find the shear force at section AAA. Okay, you have divided the section in two parts. This is the one part, this is the two part. So for this part there will be one shear force and there will be one moment. And for this part also, here it will act as shear force and again a moment. Okay, this is the beam. You are applying load at this point, but you need to find the shear force and moment along this AA section. So you need to cut, right? You will get a shear force and you'll get a moment again. And from this part, if you analyze this part, you'll have a shear force at this position and a moment. So shear force, which is also generally in most of places, shear force is represented by a word V. Okay, and moment is represented by shear force is represented by V, and bending moment is represented by M. The force that tends to separate the member. Okay, shear force is the force. Okay, the force that tends to separate the member and balance the reaction. It is giving the reference of this figure. So it balances the reactions plus it tries to it tends to separate the member. Bending moment, the reaction moment at a particular point. So due to some load and some what is will be the reaction moment? What will be the moment? Okay, a moment in if you see if you apply a load on a beam, it will buckle up, right? So there will be a moment generated, and it balances the moment Ra into X. It is giving the reference of this. So you will this is movement means it will resist Ra into X, that will be movement, and Ra will be its reaction. So from the equilibrium equation of statics, we have summation of all the forces equals to 0. Okay, if I find here summation all the forces equals to 0, so Ra plus Rb minus P, right? Ra minus V means if you see this portion, summation of all the vertical forces will be Ra minus V. Ra minus V. So I got shear force as Ra. And if I take movement about AA point, that means movement about this point. So what will be the movement? Force into distance. So it will be Ra into distance minus, because this is in anti-clockwise direction, that's why minus M. So that's why I got movement as Ra into X. Have you understood this part? I have taken this section. Okay, let me draw this section here. That will be more easier. This is my Ra. This is my Ra. I am getting a shear force. I am getting a shear force and a movement. Okay. So if I want to find summation of all the vertical forces equals to 0, so Ra minus V. Ra minus V. So I got Ra as V. Then if I want to find the moment about AA, this is my cutoff section, this is AA. If I want to find a moment about this portion, what will be my movement? Ra into X, right? And this movement will give anti-clockwise. So M, the moment. Ra into this distance, X, minus this is the movement. This movement. So I got movement as Ra into X. So it is showing that this section will have shear force of Ra. This section will have a shear force of Ra and it will have movement of Ra into X. Understood? See, this is the beam must I have given to you. It will have a reaction Ra and Rb. Then there will be one this way the reaction also, and we know this one is we generally found 0, right? So we'll ignore this part. We'll ignore this part. So I need to find the shear force and bending moment diagram for this AA section. Okay. So I have drawn the I have cut the section and draw the free body diagram of that section. So RA, C, F. So F is that distance. So I have marked as x1, x2, and x3. There will be one shear force and there will be one moment. So summation of all the forces y equals to 0. I'll get what? RA minus this P minus F minus V. So I got V equals to, this is my value. And for movement about this point, what will be my force? Number one, anti-clockwise minus M. Again, this will give you anti-clockwise movement. So minus F into x1 minus T2 into x2 plus RA into x3. So I got M equal to this part. Have you understood this part? This one is clear. If this is clear, then I can move to another part. See the diagram, see the sections, and let me know. Have you understood? Please reply in the chat box. Is this part is clear or should I explain once more? At least you can write in the chat box, right? If no response, then I will think it as that you have clear, ma'am. Okay. What about others? 28 students, but only one reply. What happened to others? Is this part is clear? And again, okay, again. Then our others, clear, clear. Okay. So see, let me start with again. Let me start with again as I got. See, this is the beam, general beam. I need to find the moment and shear force at across section AAA. So I'll divide the section. So when I divide the section at this position, I'll get a shear force and moment. Okay, I'll get a shear force and moment. And in this section also, I'll get a shear force and moment. So if I use this equation, summation of all the vertical forces equals to 0. See, I'm applying on section AA. I'm applying the forces on section AA. This is my RA and this is the section A. There I am getting a shear force and movement. There I am getting a shear force and movement. There I am getting a shear force and movement, right? This is my beam. This is my RA. This is the AA section. I am getting shear force and movement. This is my movement. This is my shear force, and this is my RA. And the distance is from this here to section A. This is the distance x, right? So summation of all the vertical forces equals to 0. So what are the vertical forces? RA positive, V downward negative. So RA minus V equals to 0. So I got shear force as RA. My V is RA. V equals to RA. So V is nothing but your shear force. Next, you need to find movement about A point. See, this is the sign convention they have shown. This is the sign convention. They have shown that I am taking positive upward direction as positive. It is saying that clockwise direction is positive. So RA, what will be the movement about A section? What will be the movement about A section? Force into distance, RA into X. This is in clockwise, so this will be positive value. Now this movement, it is showing anti-clockwise direction. See, this is the direction. So it is minus. So I got the movement as RA into X. Similar way, if I give you a beam like this, I have a reaction of RA and RB. Okay. And these are the different loads. You have been asked to find out the shear force and moment at section AAA. So I have cut it out this section. Okay, forget about this part. I need to find the section at this part. I can take either this part, either this part. Let's start with this part. I have taken this part. Okay. So I need to find the moment about AA. So I have denoted that this distance is x1, this distance is x2, this distance is x3. Now summation, and there will be one shear force and moment. As we know, we cut the section. There will be one shear force and moment. So for the shear force, summation of all the vertical forces equals to 0. So what are the vertical forces here? RA, I'm taking upward direction as positive, so RA, and these are all are in downward direction, that's why minus, minus, minus. So I got the V value from this equation. Over. Next come to the moment about AA point. Moment about this AA point. So first moment is your M, which is anti-clockwise. See, this is the anti-clockwise, right? So minus M. Again, F. This load and this distance. Suppose if this distance was in this way, then you could have taken the positive sign because this will come in this direction. Okay, so positive direction. But now the distance is in this direction, so this will come like this, right? So that's why minus fx x1, and this p will also come in this direction. So minus p f p x2, force into distance, plus Ra into force into distance is x3. This will come in this direction. That's why positive. So I got the m value. Understood? Understood? Okay. So these are the shape deformation due to shear force. Okay. Shape deformation due to bending. This will be your bending, shape of the bending. Positive shear force diagram drawn above the beam. Okay. If I gave you a beam, if you are getting this will be your positive shear force. If you are getting the value in the negative ordinate, this will be the negative shear force. This is the positive shear force. This is the negative shear force. Positive bending moment diagram drawn below the beam. Just see positive bending moment drawn below the beam. See, this is the below the beam. So this is the beam. If you are getting bending moment like this, or if you are getting the bending moment like this, so this will be your positive bending moment. So these are the shapes. This way it will be positive, and upper, if you are getting the bending moment in upward direction, means upward coordinate, then it will have negative bending moment. So this is the sign convention. This downward positive, upward negative. And for the shear force, see these two are the important points. Sign convention. Positive shear force diagram drawn below the beam, and positive bending moment diagram drawn up below the above the beam and below the beam. So next, let's take an example. Calculate the shear force and bending moment for the beam subjected to a concentrated load. See, this point load is also considered as concentrated load. That means the load is acting only at one point, concentrating at one point. Okay, so you can call it as point load, concentrated load, uniaxial load. What suits you better, as shown in the figure. Then draw the shear force diagram and bending moment diagram. So P is given to you 20 kilonewton. L is your 6 meter, that is this distance. And always remember, this distance will be from inner to inner support, not the outer. From the center line, center to center support. Okay, this is always the center to center support. So this is your 6 meter, this is your 20 kilonewton. So you have been asked to find out the shear force diagram and bending moment diagram. So let's get started. Do one thing, write this question in your copy. We'll solve by step. Okay, as we have limited time, so we'll share. I can describe some questions. Rest you have to do by yourself. So write this question quickly in your copy. Quickly. When it done, answer. Type D. When it is done, type D. Done? Done with the question? All of you wrote their question, please respond. Seriously, reopening on 22nd. I don't know. All of you wrote the question. I'm asking that. Apart from that, please don't ask anything. If you need to ask anything, text me. Okay. So this is the question. I have drawn the free body. We have drawn the free body diagram. Okay. Uh, for the roller support, RBY. For the heel support, RAY and RAX. And this is the system. And load is acting at the center. That's why it is shown L by 2, L by 2. That means this part will be 3 meter, this part will be 3 meter. And this is, how much was the P? How much was the P given? I cannot go back to that previous slide. Please type in the chat box. What was the P value? 20. Thank you. So this is the 20 kilonewton. Okay. So let's start. First find out the RAX, RAY and RBY. So by taking the moment about A, I'm taking the moment about A. So RB into L anticlockwise, that's why minus RBY into L plus this P. P into, it is acting at a distance of L by 2. So L by 2 equals to 0. So you will get the RBY value as P by 2. That means you will get 20 by 2. This is 10 kilonewton. Okay. Next, summation of all the vertical forces equals to 0. So RAY plus RBY minus T. And if you take the P in this direction, it will be positive T. And we know RBY is P by 2, or you can write 10. So you'll get the value of RAY as also P by 2. That means if you write in terms, in numerical value, RAY is equal to 20 minus 10 equals to 10. And RX is 0. Have you understood this part? Have you understood? Have you please understand? Have you understood how to find RAY, RAX and RBY? This part is over. Okay. That means suppose actually this one is telling you that when the concentrated load or point load is acting at the middle portion of a simply supported beam. Okay. And it is acting at a distance by L by 2, so you need not go through this calculation. You will understand that this RAY and RBY will be equals to P by 2. So if you know this part, it will be easy for competitive exam. You can directly find the reaction. So remember, when you'll have simply supported reactions, because in an exam if you go to solve this equation, it will take time. So suppose when a simply supported beam is given to you and load is acting at the middle part of the distance, middle part of the beam. So suppose this is making L by 2 and L by 2. Suppose this one, okay, let me give another example, that will be better. Suppose in exam you are getting a simply supported beam. Okay, simply supported beam means one support will be roller, one support will be hinge. Suppose here it is acting 50 kilonewton, and this is the distance to the total distance is 4 meters. And it is acting at middle portion of the beam. So your RA will be nothing but your 50 by 2, or you can directly say 25 kilonewton. Don't go with the distance. If I take it as 3 also, suppose this is 6 meters, this is 3 and this is 3, then also your RA will be P by 2. That means 50 by 2, P by 2. Suppose you have 100 load, you will have 100 by 2. That is 50 kilonewton. At this RA will be 50, RB also 50. So I have given a simple trick. Understood? Whenever you will get simply supported beam with a point load and it is acting at the middle portion, your reaction will be nothing but that load divided by 2. So we have found out the reaction. Now let's move to the next part. Now I need to find the shear force and the bending moment on this beam. So what I'm doing, I'm taking this section. Okay, I have taken a section between 0 to from 0 to L by 2. So I'm taking a section, suppose at this point I'm taking a text section. Okay, I'm taking a section x1. So between x is between L by 2 and 0. So you have to check at x equals to 0 and x at x equals to L by 2. So this is the free body diagram. So summation of all the vertical forces will be P by 2 minus V equals to 0. So your V will be nothing but P by 2. That means 10 kilonewton. Then moment about A. Or I have taken the axis. So moment about will be P by 2 into x minus M. So M will be P x into 2. So you got the value of shear force, you got the value of moment. Now in place of x, first place 0. When you place x equals to 0, you get shear force as P by 2 and moment as 0 kilonewton. When you put x is equal to L by 2, you will get shear force same value, but moment will be PL by 4. That means 20 into what is the L? It was complete L. How much was the distance? How much was the distance? How much was the distance? Total distance. If you have drawn the question, you will know what was the complete distance. Write in the chat box what was the complete length was given in the question. P was 20. What was the length? 6. Okay, thank you. So 6 divided by 4. So you will get some value. So at 0 means at this position. At this position, your shear force is 10 kilonewton and moment is 0. So at this position, you have shear force 0 and moment as 10 shear force as 10 kilonewton. P by 2 is 10 and moment is 0. And at L by 2, that means at this position, you have shear force, same shear force, but moment as this value. You divide 2 3 is 6, 2 2 is 4, 2 1 is 2, 0, 30. So you will get 30 kilonewton per meter as the moment. Understand this part? Then we have checked with 0 to x L by 2. Next we'll move L by 2 to full length. From L by 2 means from this position to this position. L by 2 to x. Again I have drawn L by 2 to x. So in between L by 2 to x we'll have a P value. This force. Again find the summation of all the forces. I have a force of this P by 2. So summation of all the forces minus V. This is the positive P by 2. This is the negative P by 2. I am taking section at this position. Suppose AA. Okay, so this is the free body diagram. Okay, so P by 2 minus P and minus V. If I take the whole vertical summation of all the vertical forces, P by 2 positive minus P minus V will be negative. So I got V as minus P by 2. And moment means P by 2 into the whole distance x. Okay, P by 2 into x and this P into your L by 2 distance, this distance, right? This distance. So this distance will be x minus L by 2. So this P is this x minus L by 2. And this P by 2 is acting at a distance of x meter. So I got V value as P by 2 minus P by 2 and M value as this one. Now put in place of x, put the value of L by 2 once and then L. When you put the L by 2, V will be same and M will be L by 4, PL by 4. And when you put x equals to L, V will be same, and you will get M equals to 0. See here in this question, see write the solution and replace this P by your numeric value. You'll understand. See, this is the shear force diagram and this is the bending moment diagram. How they have put, see, at 0, your shear force was P by 2, right? Positive P by 2. And at L by 2, it was positive P by 2. So see, at 0, it was P by 2, positive P by 2, and at L by 2, it was positive, right? Understood or not? Then at L by 2, L by 2 again you got a negative P by 2, and at L you got negative P by 2. So at the same point you got a value of negative P by 2, and at L distance you got negative P by 2. So this is the positive shear force, this is the negative shear force. Again at 0 you got M equals to 0, moment is your 0, but at L by 2 you got PL by 4. PL by 4, it will have some value, you need to put that value. So 0, PL by 4, again at L by 2 you got the same value, but at L you got 0. So again you connect 0. So connect this point, you will get this diagram. So this is the shear force, this is the bending moment diagram. So this is in kilonewton, this is in kilonewton. See, they have put the values now. They have they have shown by P to make you understand, but you have to draw it like that. Understood? Have you understood? Please respond. Have you understood this one? Let's find out. Okay, this one they have done with numeric value. Let's start with this. Calculate the shear force and bending moment for the beam subjected to a concentric load as shown in the figure. Then draw the shear force diagram and bending moment diagram. So this is the again a new beam with simply supported loads and one point load. 3-meter distance, 5-meter distance, and this point load is acting at different distance. Earlier the distance was similar. Okay, that's why we can say, now we cannot say that the reactions will be 15 by 2 here, 15 by 2, because the 15 kilonewton is not acting at the middle portion of the beam. Okay, so this is the free body diagram. Use the three equations of equilibrium to find out the support reactions. So RBY they have found 9 kilonewton, RA they have found 6 kilonewton, and RX equals to 0. This is the first part, very easy. Draw the free body diagram and find out the reactions. And this will be the shape of your shear force diagram and bending moment diagram. Let's understand this one. Okay, how they have found out. So if I take a section, see, for this beam, I will need two sections. One section and this one. Okay, suppose this one is A by A and this one is B by B. So I'll have a condition between, I'll have one condition, so I'll have one condition as X less than this 3 meter, right? Less than 3 meter, but more than 0 meter, this 0 meter. Next condition I'll have, for this condition I need to find the shear force and bending moment equation, and for the second condition will be X should be more than this 3 plus 2, 5, and it should be less than 3. Understood these two conditions? These two condition is clear. I'll have two conditions, one section which is X will be 0 to 3, from this 0 to 3, and in the second condition I'll have from 0 to the whole distance 5. Okay, so forget about the second condition. Let's start with the first condition. Sorry. So let's start with condition number 1. I'm making a section at this point AA. Okay, so let's draw a free body diagram for AA. A, A, I am getting a reaction RAY, right? RAY, which is suppose at a distance of x meter, and there is no shear force acting. So what will be the summation of all the vertical forces? There will be one vertical force, right? So it will be RAY minus V equals to 0. So our V is nothing but your RAY. Understood this part? And V is RAY. So how much is RAY? It is nothing but 6 kilonewton. Have you understood this part? Please respond. Have you understood this part? Have you understood this part? I cannot move if you don't reply. Have you understood this part? How I got V equals to 6 kilonewton? No one is replying. Say 6 kilonewton. 6 kilonewton I got. So I was okay. So see, for this beam, load is acting. So and if I make a if I take two sections, that is one section from 0 to 3, that is x is less than 3 but more than 0. That means this is the condition. And again I can take the second condition, x is more than 3 but less than 5, because 3 plus 2 is the last distance is 5. So these two conditions I have to take. That means I have to take these two sections. So let's start with the section 1. Section 1. I'm taking a section at a distance of x. If I draw the free body diagram, this is my x, this is my x, this is my RA, which is RAY, which is at a distance of x meter. And you know, at a section you will have one vertical force and there will be one movement, right? So if I say find out the summation of all the vertical forces, so you will have RAY positive minus V equals to 0, right? Now your V will become RAY, right? Which is nothing but RA is how much? 6 kilonewtons. So your V is equal to 6 kilonewtons. Clear? Now clear? This part is clear how I got V is equal to 6. Okay. Those who will say me yes, then I'll move forward. So V part is clear. So at 0, we have found it for the first condition, we have found it the V value. Okay. Which is 6 kilonewtons. Now we'll move to the movement part. Now movement about this XX section. So what will be? RA into X, RAY into X minus this anti-clockwise movement equals to 0. So my movement is nothing but RA into X, which is RAY is how much? 6. So 6x. Now I have V is equal to 6, M is equal to 6x, right? And I have a condition of X from 0 to 3. So 0 to 3, right? I have founded the V value, I have founded the M value. Now I need to find the value of x. So when my x is 0, so when x equal to 0, your v will be same 6 and m will be, if I put x equal to 0 in 6x, I will get 0 value, right? 0. 6x, and if I put the value of x equals to 0, well, I'll have 0. Next, when x can be 3, that means this distance. So my v will be same 6 kilonewton and my moment will be 6x, right? So 6 into 3, it is 9 kilonewton per meter. So at 0 I have v6, at 3 also I have v6, and at 0 I have a moment 0, and at 6 I have a moment of 9 kilonewton. See the diagram. At 0 I have a 6, and at 3 also I have shear force of 6. So I have drawn the shear force diagram, this part or this section. And at 0 I have 0, and at this point I have a 9, so I have drawn a 9. This is 9. It was 9. It was 9 or 18. We'll see. Maybe uh, addition on. So clear? Then I'll move to the next condition, which is x less than 5 but more than 3. That is this section, right? Okay. So next I have a condition of x less than 5 and more than 3. Let me add them. Okay. So next condition I have x is less than 5 and more than 3. So I'll have section here. So I'll draw the section. Bit now. This is the section where 15 kilonewton is acting at some point. Suppose this is the RAY, which is at a distance of x meters, and this from RAY to 15 is 3. So how much this one will be? X minus 3, right? This is the x distance, and from RA to 15 this is 3 meters. So how will you find x minus 3? So this is the x minus 3 distance. Now summation of, and in at this section I'll have one shear force V and one moment M, which is 3, right? So summation of all the vertical forces RAY, which is positive, minus 15, right? This is the downward, again minus V equals to 0. Now and we know RA is 6 kilonewton, right? So 6 minus 15, if I take V on that side, V will be this. Now V will be 15 minus 6, minus, how much it will be? 15 minus 6. Okay, what will be the 15 minus 6? You guys just attending the class, no response. Solve in your copy.
9.
Huh? Yes, I'll get a 9. How it will be 9. 15 minus 6, 9. So I'll get V minus 9. So see, I got V as minus 9, right? Next, let's move to the movement part. Now let's move to the movement part. Okay, let me draw. Okay, now let's move to the movement part. Now movement about this XX section, right? So RAY into X, RAY into X, this is the clockwise direction, minus this 15 is anti-clockwise direction, 15 into, this is the distance, x minus 3. So this will be the x minus 3 equals to 0. Okay, now I have one more movement, minus m. Minus m equals to 0, right? Now if I take that movement, so from here I'll get RAY is 6, so I'll get 6x minus 15 into x, 15x, minus minus plus 15 into 3, 45, equals to m. So my m is 15 minus 6 equals to 9x minus 9x, because minus 15 is big, plus 45, right? So my moment equation is, let's write it as 45 minus 9x, right? So I get two equations for the second condition. For x equals to, for x less than 3 but more than 5, I got two equations, one for v, one for m. So v will be same, as there is no x value, so v will be same for both the conditions. X is equals to 3, at x equals to 3 it will be minus 9, and at x equals to 5 also it will be your minus 9. But your movement will change because it has x value with it, so it will change. So how it will be changed? Let's see. See, this is shear force and bending moment is very interesting. Do it by yourself. I'll give some questions. Do it. So I got this equation: v equals to minus 9, m equals to 45 minus 9x. So at x equals to 3, I'll have v as same, minus 9, and m will be your 45 minus 9 into 3. So 45 minus 9 3s are 27. So how much it will be? 45 minus your 27. 45 minus 27. You'll get 18. Your movement is 18. So at x equals to 3, your v is minus 9, m is 18. Now at x equals to 5, v will be same, minus 9, right? Your m will be how much? 45 minus 9 into 5. 9 5 are 45, so 45 45 minus 0. So at x equals to 5, you have v equal to minus 9, m equals to 0, and at v equals to minus, at x equals to 3, you have minus 9 and 18 value. So you put this value, you will get this figure. See, minus 9, minus 9. At this, from one condition you got 9, and for another condition you get 18. So take the maximum value 18, and at another point you got 0. So join this. You got the free body diagram. Isn't it easy? We'll see the UDL in the next class, but you write this question. Write this question first. Write this question first. Write this question, then write that question. Do quickly. Write, solve this question, and so write this question and solve by yourself. Quickly, write this one, and please write your roll numbers in the chat box. Simply supported beam with point load. Load is 20 kilonewton, L is 6 meters, and draw the shear force and bending moment diagram. Done. This part is done. And another question is simply supported beam with 15 kilonewton load and 3 meter and 2 meter distance. All of you write your roll number in the chat box. Done? All of you wrote their roll number?